For the following problem, we want to divide using synthetic division, then long division. We have x to the fourth plus 3x squared minus 2x plus 1, all divided by x minus 2. To begin this problem using synthetic division, we first have to find all of the coefficients of the first polynomial. The coefficients are the numbers in front of each x. So if we list off this polynomial, x to the fourth plus 3x squared minus 2x plus 1, notice that we are missing a polynomial. We're missing an x value, so to say. We are missing an x cubed between the x to the fourth and the x squared. So if we were to rewrite this problem with that x cubed included, then it would technically be x to the fourth plus 0 x cubed plus 3x squared minus 2x plus 1. And now that we have it written like this, it's the exact same problem, but we now have the coefficient that is in front of the missing x cubed term. We can now take away all of the coefficients. So in this case, we have a 1 in front of the x to the fourth, then a 0, 3, negative 2, and finally a 1. We will need these numbers for the synthetic division, and that 0 will be very important. The last thing that we have to do before we can start performing synthetic division is to find our c value. And the c value is the number that you're dividing into all of these. And it comes from this x minus 2 term. So synthetic division only works when you have x plus or minus some constant, in this case minus 2. And what you do is you want to take that x minus 2 and set it equal to 0. And you're going to solve for x. So we'll add 2 to each side, which gives us x equals positive 2. That is our c value. I'll even put a little c here to note that. And c always goes on the outside of the synthetic division. So we have 2 for our c value, and we show a little mark, half a box, to show that it is separated from these other coefficients. And now we can begin synthetic division. Okay, so the way synthetic division works is we're going to take our first number and bring it down. So we bring down our 1, and now we multiply that value by 2, which gives us 2, and we put it below our second number. We then add these values together, which gives us 2, and we repeat the process until we run out of numbers. So we're going to take this 2 and multiply it to this 2, giving us 4. Then 3 plus 4 gives us 7. We take that 7, multiply it to our 2 again, that gives us 14. Add that to negative 2, we get 12. Then take our 12 and multiply it to 2, we get 24. And adding 1, we get 25. And the way that synthetic division works is these values represent the coefficients of our quotient. And this final value, I'll box it off, represents the remainder. And you always start with the next largest exponent. So notice in our first polynomial we had x to the fourth. We're going to start with x cubed. So that means we have 1x cubed, or just x cubed, plus 2x squared, plus 7x, plus 12, and finally the remainder is 25, and your remainder always goes over the divisor. So we get plus 25 over x minus 2. This is just like when you divide with regular constants. When you have the remainder, you put it over your divisor and you put it as a mixed number. For instance, if you had something like 10 divided by 3, when you end up dividing this, you get 3 with a remainder of 1. So you would say your answer is 3 from this 3 here, and your remainder gives you 1 over the original divisor, which was 3. So 10 divided by 3 is 3 1/3. X to the fourth plus 3x squared minus 2x plus 1 divided by x minus 2 is all of this plus 25 over x minus 2. It's the same thing, it just looks a bit different. Now we're going to go through the problem using long division. And long division will work very similarly to how we did long division in the past, in arithmetic, pre-algebra. We're going to set up our divisor on the outside of a half box, and we're going to put our dividend inside of it. So we have the x to the fourth plus 3x squared minus 2x plus 1. And now we want to check. So I'm going to separate these problems. This way it doesn't get too confusing which one is which. Now we want to check how many times can our first term on the outside divide into the first term on the inside, just like with standard long division. So we get x to the fourth divided by x. We only care about the largest terms of each polynomial. So x to the fourth divided by x is just x cubed. So we're going to put that x cubed at the top. And now remember, whenever you did long division in the past, you would take this value and multiply it to the number on the outside and then subtract it from the number on the inside. We're going to do the same thing. We're going to take this top number, x cubed, and we're going to multiply it to the number on the outside. In this case, it's a polynomial on the outside. It's x minus 2. So when we multiply this, we have to distribute. That gives us x to the fourth minus 2x cubed. And remember, we are subtracting this. We always subtract this value in long division, which means we're going to multiply it by a negative, giving us negative x to the fourth plus 2x cubed, which we'll put down here. Okay, and now we want to add these polynomials together. So adding them together, x to the fourth minus x to the fourth cancels out. 2x cubed does not add to 3x squared. They are unlike terms, so we'll write them separately in order. We have 2x cubed plus 3x squared minus 2x plus 1. And now we're going to repeat the process all over again. X divides into 2x cubed leaving us with 2x squared. So we know that we'll have a plus 2x squared in the top. And again, we will multiply that to the outside number, 2x squared times x minus 2. And in this case, we'll do 2 steps in one, because once we multiply these, we will be subtracting the results, which means we could just multiply by a negative 2x squared. If you prefer to write these out as 2 separate steps like I did above, that's perfectly okay as well. So we'll distribute this, giving us negative 2x to the third plus 4x squared. So that leaves us with negative 2x to the third plus 4x squared. Oh, and then, sorry, I got a little bit ahead of myself here. Now we're going to add them together. And here the 2x cubed will cancel with the negative 2x cubed. The 3x squared plus 4x squared are like terms. They will add together to give us 7x squared. Then minus 2x plus 1. And now, as you can imagine, we're going to keep doing this until we can no longer divide the first terms. So I'm running out of space on the right. I'm going to jump back over to the side that we did the synthetic division on, just to show the work. We're dividing 7x squared, our first term, by x, our first term on the outside. That gives us 7x. And again, that goes in the top, plus 7x. And remember, we take this value and multiply it to the number on the outside, which is x minus 2. And because we are going to subtract this result, we can again just multiply by a negative immediately, giving us negative 7x squared plus 14x, which goes right here. And now from here we can combine our like terms again. The 7x squared will cancel with the negative 7x squared. Negative 2x plus 14x gives us 12x plus 1. And finally, we can do this one more time. We have 12x divided by x gives us 12. So that goes up top, plus 12. And again, we take our value, 12, and we multiply it to the number on the outside, which is x minus 2. And we distribute a negative as well. So when we distribute this negative 12, we get negative 12x plus 24. Which we write down here, negative 12x plus 24. And like always, our first terms will cancel out. If this doesn't happen, it means you did something wrong along the way. So our 12x will cancel with the negative 12x, leaving us with 1 plus, oh, that should have been a 24. I got a little bit ahead of myself here. 1 plus 24, which then gives us 25. And at this point, 25 cannot be divided by x. It'll just give us a rational expression or a fraction involving x's. So, like we did in long division in the past, we take our remainder, which in this case is 25, and we divide it by the term on the outside, x minus 2. And this polynomial is our complete answer. Notice that it matches perfectly with the polynomial that we got from synthetic division.